here a little bit. So we're going to talk about some R. We're going to talk about the Titanic and how we can take the data that's in there. Here, let me screen share real quick, and we can kind of look at the Kaggle, I don't know how you pronounce it, Kaggle? That's what I've heard. Whatever. There's so when you go to the Kaggle.com, one of the first things it says is, hey, if you don't know what you're doing, start here. And it's the Titanic. So they give you a data set, and let me bring it up so you can see it. So this is a, let's see, can I bring up, I don't know which one I wanted to bring up. Is this one? Here. Let's try that one. Maybe that's not the one. Which one's the one that I don't know, it's doing that crazy thing again. The crazy thing is to get to, once you start presenting, is to get back to there's another tab in here, or another pane, but the Hangout kind of took over it. Let's see. That's not it. All right, so let's see. I'm not sure. Let me get back to it and just share, make sure I share everything. Screen share, entire screen. Share. There we go. Infinite loop. Check it out. Yes. All right, now in here, I think there. Okay. Yeah, if you've got the Hangout window, it keeps looping and looping and looping. All right, so here it is. Go here. You create an account. I have an account. I guess I'll have to log back in. Competitions, data sets, blah, 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 blah. Competitions. And the first competition, right, here it is. New to data science. Start here. Right, so Titanic, machine learning from disaster. There's lots of projects in here that you can do. You can, some of them are paid, some of them are not. You can win money if you predict cancer, things like that. There's some things in here that I think that are actually winnable. So, right, so you start here if you're trying to figure it out. So, the Titanic sank. Here's how many people 1502 lived after. No, 1502 died out of 2224, right? So how can we take the data set, and they've taken the the ship's log or whatever, and they've marked the information about them. I'll show you in here in a minute. Marked information about them, whether they lived, whether they died, a bunch of other stuff. So you can do some things, kind of simple brute force. Well, women and children first. Well, that'd be a pretty good guess at your first crack at who lived. Of course, it wouldn't be complete, but it's a reasonable educated guess, especially for what, 1912, right? So, right. So, and it tells you, what kind of skills you can work on here. Binary classification. You can use Python or R. You can use whatever you want, but those are statistical champions for languages. Here, there's leaderboards, which is kind of who's doing the best. This is just open. The what do you call it? The task or whatever, it never ends, or I don't know, it goes on for 8 years or something. So, right, this thing here shows 5 years ago they started it, and it's going to close in 3 years. But I don't think they'll ever close it, right? It's a good practice set of data to work with, right? So, leaderboard. There's as you look through here, right? I'll show you the tab of the data, but there's leaderboards, right? So there's the public leaderboard, which is just everybody who signs up and gets an account, messes with data, comes up with prediction and uploads it, and then you score, you rank, you'll be ranked, right? So this is the public leaderboard. There's also a private one. I don't know if we can even see that, right? So, well, after the competition ends, I'm not sure what this is, and I think there may be some other variation of the testing that you could do to get in there. I'm not sure. Discussion, people talking about it. Kernels, I think these might be some people's code or predictions. Here's the data. Right. So it's a test set and a training set. If you're doing any kind of machine learning, you take some subset of the whole set of data to work with. I don't know, 20% or 40% or something like that. And you start with that. You try and build a prediction around that. If you try too hard and you get do it manually and build every edge case in that you can find, you will have coded or scoped yourself so specifically to that data set that when you go and try and use it on your test, on the actual test set, or another set, some other ship that sank, you will have been so specific to that set of people on this boat at this time that it won't work as well in other scenarios. So you want it to be generic. So you don't want to you don't really want 100%, because then you'll have coded in every possible scenario that's just not the way it works, right? So you want this to be automated with your own set of generic findings that you can apply to the rest of the data set. So that's kind of the website. There's lots of other competitions. Let's see. Do they have any in here? Right, here you go. Right, can you improve lung cancer detection? And there's a prize, pretty good prize, if you could do it. So there's these other ones that have prizes and stuff. So, I don't know how well they work. I don't know. Nature Conservancy Fisheries Monitoring. So that sounds neat and coastal to me. So that would be something cool to put a team around and mess with and see what that's about. So I think
at the bottom, it's $25,000 prize.
There we go. Sea lion population count. Huh. So who knows? These are neat things. I think this fisheries one I think they want you to classify the species of fish. I think there's 3 kinds of fish, and they want you to be able to classify it. So really it would be it's a visual detection thing. So they want something like that. All right, so that's that. I've got our studio set up with some things, right? Some code and some stuff to kind of look through how it could be done, or how pieces of this could be sorted out, right? So like I said, kind of like what would you do? How would you go about the problem? A bunch of people died and a bunch of people didn't. So how, what some things, women and children, age. Let me show you also, I actually have the data sets in here. So you can kind of see what's in here. All right, so here's the training set. Where is the pretty viewer on that? Is this it? No. How did I see that pretty view of this stuff? Import data set. So the training set. So in our studio, if you import it, this is sort of like Edgar was showing last week. You can tell it how you want how is it comma delimited? What is it? How is it separated? And it'll make it look like nice in the spreadsheet, so you can see it easier without being a mess of comma separated yuck. So here's the, the fields that are available, right? There's a passenger ID, and that doesn't really mean a whole lot to anybody other than just, this is how you will be scored. So the submission they want is a passenger ID, and did they live or did they die, right? 1 or 0, right? The survive business here. Well, this is our training set. So in the test set, that column doesn't exist. You need to fill in that column, right? So class, what's P? Proxy class, first, second, or third class, right? Price ticket. Of course, first class is better. You're above deck and other things. So maybe that would matter. Name, you will see farther in here. I don't know if I don't think that I've really played with it, but the last part of this, which is, we won't have time to get into, but I'll send the links to this tutorial that I went through to talk about some of these things, is they took the name, and some of these things, I don't know, can we find one in here that's, sir, such and such. Well, that's like, that's somebody high up in society. I don't know if there was a duchess or something on the boat, so she probably is going to make it off of there, at least get into a lifeboat, Elements get the person maybe, but would have had a good chance at it, right? The sex, age, siblings and spouses, and then parents and children, how many. So that's kind of where you get into like a larger family where they won't split up, or maybe they will split up. Howdy. Ticket fare, how much you paid for the ticket. So, right, you could be first class, but maybe first class could be, the top 3 decks, and as you get higher, the price is higher, or something. I don't know. What cabin you're in, and where you embarked from. There's 3 different towns they picked people up in, I guess, on their way over. So there's a bunch of things in here that you could look at. There's ways that you could combine these. That, the name, you can slice and dice the name and look for those titles or different things. You might be able to figure something out. So that's the data, right? So you look at the data, you take, get an idea of what's in there. How could you maybe chop it up or recombine it to make it kind of a factor that you can decision on. So that's the data set. Training, I got 2. Well, that's just the CSV, right? So in R, that you import the data set, and it takes it from the nasty thing and turns it into sort of Excel looking. We saw that last 2 weeks ago with Edgar. So in R, there's you were asking how is R? It's it's sort of Perly. It's a scripting language, but it's handy, right? So in R Studio, and I can kind of go over this a little bit just quickly, right? So you've got your code window here, tabs. It's handy. This is sort of an environment debugger, so it'll show you your objects and what's in them, and you can inspect them here. Files, plots. This is things that you generate. You'll see I'm going to generate some plots here in a little while. Packages, things that are loaded in here. So this is sort of your file viewer. And then down here is a console window. So this is like if you're at the shell. You can interact directly with stuff in the shell, as well as you can run. And Edgar was doing this, but he didn't say it last time. But if you was a command enter on my other laptop is different, so I'm not sure. Maybe it's shift enter. Nope. Command enter. There. So command enter, actually you'll see below here, right? It actually ran the command that my cursor was on, right? So you set your working directory to where all these files are on my laptop. Dir was just a directory listing. Reading files in, we saw this a little bit last time, read.csv. There's read. All kinds of stuff and flags and all kinds of things you can pass in to have the commands do things differently, different delimiters, whatever. You can have things read in, right? So whenever you're doing any of this kind of stuff with any data science and manipulating with data, right? So there's going to be bad data in there. So in this case, I just happen to know because I've looked at it and stuff. There's right. You'll have of those columns that they supplied, right? P class, right? Well, some of them don't have anything in there, right? It's null or NA, not there, right? So what do you do with that? You can't really. You've got to come up with some best guess at how you're going to fill that in. You're just going to take a wild guess, and there's ways to do that. You can just just default everything to something. If there's not a sex in there, make them all male, okay, or otherwise. Or you can kind of figure out. Maybe you could figure something out based on name. If there was a Mrs. in the name, then you kind of have an idea. It's probably not a guy. So you got to clean your data a lot of times, or be able to deal with the things that are not normal. So I know there's some of that in here. We might address some of that here a little later. Right, so, right, read in the training data set by running this command enter or return, runs the line. At this point, I have this object, and you can see it over here. Right, here it is, this thing. So it actually loaded it. But then you can also, on the console, you can just type the name of the object, and it'll spit it up. It'll spit most or a bunch of it out. It only spits so much, but you see it omitted 58 rows, right? So it gives you a sample of the data. So you can look at it, right? So you can see that QSC. I don't remember what that is. What is that? Whatever it is, you can see there's holes. Right, there's this one line here is missing whatever that is. So if that's a piece of data that we cared about, we'd have to figure out what to do with that. How are we going to either intelligently guess or just brute force just put something in there? Well, I like the letter Q. That's what it's going to be. Anyone that's not there, I'm going to make a Q. So back to this. Something else you can do is run summary. And get a summary of the data. There's str, kind of gives you an idea of what's in there in your data set and what data types are in each of the columns, right? So passenger ID is an int, and here's all the possible values, and ... mean it goes on forever, right? So this could be, right, this is going to be sequential up to whatever. I don't know if this is the whole data set or I don't know if it's the whole. I know that the training set, I think is like 800. I think it's 800 rows, 800 people. And then the remainder, I don't know if it's the rest to get you up to 2,200 people or not, but it might be. I think it's less though. I don't think they actually use the whole data set. So then there's things like we talked about last time. There's factors, right? So factors, name is a terrible one for factor, right? Sex is a good one for factor, right? There's two. There's male and there's female. Now, if we had NAs or something, you'd have a third, unknown, right? But factors is the unique subset of all of the values that are in the field. So that's an easy one. You'll see age, right? Here's someone that doesn't have an age. So age probably matters, could matter, right? Older people, maybe not as lucky as younger people. Younger people can run and jump and swim and maybe have more stamina, whatever. So you would want to deal with that probably. So that's the way you can look at it at the data, right? So that's str. There's also summary. What is this? The training, right? And this gives you kind of some statistical information on the values for each of the columns, min, max, mean, some statistical ideas of what's in there, and some of this may be useful and some of it's not. Name, who cares, right? But some of the other things, age, could be useful, right? So, you know, you can see there was young, the majority of people were, I don't know, that seems reasonably young, maybe married or honeymooning or something, I don't know. So what does that mean? That might mean something. So you could think about that as you start formulating ideas about how you are going to approach predicting. Well, maybe that matters. Maybe you want to focus your net on that group of people, or right, the max was 80 years old. Maybe it was women, children, and elderly people first, so maybe they did better. I don't know. That's the kind of thing you would think about and look for. Other ways to see stuff, right? So you can run table. And that, so in this case, I ran this command to kind of summarize survived, right? So 549, 0 is false, 1 is true, it's positive, it's Boolean logic there. So, right, so 342 out of the 800, whatever it is, 890, survived, 549 did not. Then you can also get proportions of, right, you can get the proportion, instead of just being the raw count, you can get the proportion of it. Yeah, so 61% died. Done. Now you may want to break it up, right? So you can start thinking about, all right, well, let's see, you know, does it hold? How many women versus men? You know, so you can, all of these commands are here that you can quickly just start playing with it, playing with the data on the command line real quick, especially once you start knowing the commands and knowing the data set. You can start messing with it pretty quick, especially if you've got an idea. All right, so there's females and males, but you know, what else can we look at? Right, so here I guess we looked at age, and I think there was some of them. I showed you there was NAs, right? So this command summary on just that column, on the age column, well, there's 177. We don't know how old they were. So what do you do with that? That's a hole. If you were going to use that as a useful factor in who survived, which you probably do want to do something with that. So what else? So, you know, women and children is one of the first things that you would think of. So you can, you know, there's age, and then there's all these NAs. So, you know, the way that's kind of taken here is, you know, well, if they don't have an age, just assume they're older and not children. So you can default, right? And we can set on our training set, which is that big table of data, we can create on the fly, $child, we can add this field into the set and initialize it to 0, right? So nobody's a child, 0 is false. So we're going to add this child column onto the data set. Then we can say, all right, so for any of the values that are less than 18, right, any age column in the training set that's less than 18, we're going to set it to 1. So anyone under 18 is a child, right? So we can set, so we're kind of creating a new column on the whole data set so that we have that to work with, right? So that makes it easy. All right, now we know who's the kids. We're assuming everyone who doesn't have an age is not a child, they're older. And that's just, you know, maybe that's the wrong thing to do, but you can always change that later and come back and say, well, what if I assumed otherwise? Or what if I split it in half and just randomly chose that, you know, does it work? Or you could just exclude them completely and just model based on what you do actually really know. Right, so now we can take, and the best way to look at this, run it so you see what it outputs. So this command, you're going to aggregate over. So we're pivoting on, we want to know the survived did they survive or not, based on kind of the squiggle, the tilde is sort of based on these two fields. Is it a child? And what are they, male or female? Right? So this is the syntax for creating that set of data, sort of buckets it that way. The data set we're using is the training data set, which is loaded in here, the train variable. And then we're going to apply a function. And so you sort of inline, I guess, sort of lambda, I don't know. You inline, you can define the function that you want to run for every column or for every row that comes back, right? So you're going to take the sum and divide it by the length. So for the sum of male children, divide it by the length of everything. So you can come up with individual percentages for each grouping, right? So, you know, this spits it out in a way where you can look at it, right? So female women, of the female women, 75% survived. Of the female children, 69% survived, right? So you've got ways to look at the data, which can give you some quick insights that are really useful. So now you can start cooking more. So just in and of itself, I think, let's see, right? So here is more just basic R stuff. So we need to, what you need to submit at the end of this thing is a 2-column, basically, you know, spreadsheet or comma separated file of the passenger ID and a 1 or a 0. Did they survive? So we're going to create a data frame, which is just one of those tables here. Boom. Whoops. What did I do? I didn't run everything. Probably. It's missing some of this data. Let's see if I get it that time. All right. So now if I just type some, whoops, not there, down on the command line, submit, right? Boom. There's this thing of all these values. And if I scroll up to the top here, right, passenger ID and survived. So there's the numbers and there's the values. So this, at this point, and similar to read, there's a lot of ways to write, and you can, you know, how do you want to delimit it? And do you want to put the row names in, column names, whatever? So we're not putting in the row names, but we are putting in the column names, what you saw. If you run this thing, it'll spit it out, and it's right there. I had run it before, but this is the gist. It rewrites this file. This is what you upload to Kaggle. Let's see. I haven't uploaded one. I've got an account. Oh, I didn't log in before, did I?
Yeah, let's see the tilde is.
It's like over. Do this over these fields.
Gotcha.
So based on these different points. So it's going to kind of take every combination of that and
It's like a for each.
it's every combination. So male children, female children, male adults, female adults, and it does all of the math to figure out how much in each bucket based on you running this function across all of that, right? So for each male child, how many are there that survived, which X is kind of this thing that you're pivoting on, divided by how many are there, right? So you end up with this percentage. Not the most obvious thing ever. I'm trying to remember. I've seen that sort of syntax before, but I can't remember where. Does Python have anything like that?
You can do list comprehensions in Python to get
Similar kind
like
of thing?
all the combinations of, say, like you can do for X and 1 to 10, for Y and 11 to 20, and you'll get one.
But that's like an iterator over those, right?
Yeah, but it'll take the two lists and it'll
kind of combine them and
it'll do every combination of each thing in the list.
Yeah,
Each thing in the list.
similar, yeah.
But I mean, pandas, which is the Python library for that does a lot of the similar stuff to R, has ways that you can manipulate data frames to do aggregation.
Same kind of deal. This is how they do it here. It's neat. It's kind of weird to look at it first, and you'll see farther down. Farther down here, you can put a lot more in there, and you end up, and then you build a model. But you can build your model based on bunches of numbers of the fields in the file. So let's see. I haven't submitted one of these, so we'll see. Let's do it and see what happens. Let's see if I can figure out how to get to. Actually, I got to log in. Good golly, what is it? Sure, save it. Hey, look, I'm a goose. Is that me? That's not me. Pretty funny. All right, so competitions. I'm probably in this competition already, or I've kind of downloaded the file, so maybe it'll know me or something. It'll let me do it. So submit predictions. Okay. So I've read places where you can have like 7 submissions a day or something. Apparently you have 10 now. I guess they changed it. So let's see what happens if we submit this one. No, not self-signed certs. Let's go to, whoops, I just saw Titanic down there. Right, so what was that one? Send. All right, so I sent it, and then what happens? I don't know how long it takes for them to actually do it. Oh, first try. I don't know. Submit, see what happens. All right. Does it show me somewhere? Or do I have to find myself in here? That would be terrible. Where's that? Where did it say that? Oh, hey, hey, how nice. 76%, right? So there you go. So just basing on, what did we base it on? Females, I think. Yeah, so were they female? So that gets you 76% accurate, which, I mean, when you look at the data, it was pretty much, when we looked at this thing here, right? Female, 75%. That was female adults, though. Still, female children, 69. So you're pretty close. I mean, well, sort of close. People get a lot closer than this. So this is the first pass at just whacking at it, right? So, let's see, I don't know what I changed in here, but we'll save just in case. Right, so that's the one way, right? That's the brute force first pass of let's just pick something out and just make the assumption that these people lived and guess. And it will take that. And apply it to the, right, so we applied it to the test set and set all the females to they lived. Pretty dumb, but it kind of works. All right, so you can get a lot more fancy about it, right? So you can go in and actually start fitting models and setting up decision trees on these. So there's a couple of packages in here that are neat to help you look more looking at data, right? So you can see what I did here, right? So here's more of this survived. We're going to fit a model to a set of data. We're loading in a bunch of visualization and partitioning package. So we're looking at survived over right? So now there's their class, their sex, their age, like everything, right? So what does it mean? If you look at everything, so if we fit that, you can then, it gets progressively nicer, right? So you can run plot on it, which doesn't show you a whole lot, but this is going to be the decision tree. So, probably the first one's probably on sex. I don't know, but we'll see. So then we can add some text onto it. Let's look at it real quick, right? I chopped it off the top. But you can see that it's determining its own decisioning points. What matters the most, or what it has determined based on all those things. When it slices and dices and mushes them all together, what has the biggest breaks? Right? So age, and then number of siblings and spouses over 2.5, right? How much your fare was, if you was higher, right? Over here, where you embarked from, blah, 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 right? Your class, if your class was greater than 2.5, it's figuring this out for you, and it's saying, all right, I've got a model. So let's see. So now if you do the fancy, whoops, zoom into this. How do I zoom? I can't even see this. Let's see if I do this. Does that help any? That's terrible. Can you see it? Well, so this first one is sex equals male. If yes, go left. If not, go right. Right? Then it's based on age over here. Greater than equal to 65, you go over here. Less than, you go over here. Then this is the number of siblings and spouses, I think. So it looks terrible here, but it's because I'm sharing my screen through a YouTube Hangout. So not the neatest thing ever. If you run the code, get RStudio, run it when my screen's not doing this weird thing to fit that broadcast, it looks good. And you can read that. So we fit a model to all of these things here, right? So then you plot it, which is ugly plot. This has some text on it. This makes it nice bubbles. Here, you can actually now run your test data across this model to see what happens. You can fit your data onto it, predict what happens, right? So we can run that. And at the end, so now we've got this prediction, right? We got our prediction. There's our passenger IDs, and did they live or not? All this happens magic. You just have to know that this stuff is there, and how to build your models, and so you can create another submission. So we're doing the same thing that we did before, getting a passenger ID and whether they survived. With the test data here, which is what we predicted, and filled in that column. So now we've got another one called decision tree, and now we can go back. Other way. See if we take decision tree. Upload another file. This one was this decision tree. Submit. Oh, they had to put some more hamsters in. Okay. Whoop. All right. 78. So what was it last time? 75-ish?
Yeah.
Right? So that did better, taking into account and just letting, we'll go back up to the top here. So letting the model, fitting the model just by itself was 78. Now you can there are parameters where you can tweak how the model what its default values are for like partitioning kind of thresholds, and the number of values per bucket. You know, only go true, or for a certain amount. You can limit how many go to each side of the decision trees, or of the branches. So you can adjust this if you know better than it for whatever reason. So you would have to, you'd have to know why you'd want to tune that. So then, so then you can move on to random forests, which is lots of decision trees. So you go through bunches and bunches of trees. I don't know that we'll necessarily go through all of this. We can give it a try. But you can improve on your score even more. We can stop for a minute. Does anybody have comments? Does anybody have additional thoughts or comparisons to perhaps Python? Or has anybody done this with Python to show, at least at the level that I've done, the first couple rounds of how you would go about?
I've been intentionally redoing it with R, using other people's examples. I found a pretty cool example of it packing out reverse engineering.
Mm-hmm.
Charted all of it out by class, and sex, and passenger, and all that.
Mm-hmm.
Made some pretty awesome charts with it in the R Studio. But he included a secondary charting library to do it. I've just been using his as a base and going backwards from there. He's a German guy, so a lot of the comments are in German. So if you go back or forth that, Google Translate.
Right.
Yeah. Nothing like stats that are in German, right? But yeah, so there's some really cool charting libraries you can use secondarily.
Yeah, and yeah, I think I got this. So I got this from this Trevor Stevens guy. He's got a cool tutorial on all this stuff that walks through this, and he talks a lot more about it. But it's all the same general idea. What's in there? How do you make sense of it? And this is, this is an easier data set because you kind of know what happened and whatever. But
they all survived, right?
Well,
it was unsinkable.
There you go.
Right?
Well, there's no because on a lot of cab competitions, you'll train on something and then it's a data set you don't know anything about,
right? That
you try to predict on, and you don't have that here. You don't have a
right
second Titanic to
right. That's I was saying before. I don't know if you had walked in, but if you tune too specifically to your training set, which is 1/3 of the Titanic passengers, and you make it 100%, and you nail it.
Right.
Well, when you run it on the second 2/3, you might do good, but then if you run it on some complete other scenario, you will have overfit your model to the set of data that you had to work with. So yeah, you could be really off.
Like your model can be just a simple a dictionary that has the names and then a 0 or 1 based on whether they survived, and it would predict that data set perfectly, but it wouldn't do anything on another data set. So, because I noticed the guy at the top had 100%.
Well, there's a bunch of them that do.
Right.
Yeah, and it's funny at the bottom they says this information is available on the internet anywhere. You can go and get it. Yeah. But don't do that because that defeats the whole purpose.
I mean, I have an IPython notebook that for a nano degree that I did that just has like exploration. I don't fit a decision tree or anything like that. I have another data set where I have done all that in Python, but I mean, I'm glad to show just, you know, sort of the basic functionalities. It does have some code behind it that just makes it easier to do things like graph and filter the data, but it's not really necessarily
right.
the way you would work with a data frame in Python. It just sort of makes it easy so that you can just sort of go through, look at graphs, and make the decisions like you did in the first case where you said. And I think I end up with like 80% at the end.
Yeah, let's see. I wonder, are you in the can you join the Hangout and share your screen? Because that would be super awesome.
Yeah, you got a link.
Let's see. Yeah, so you see, this is like this. What I'm scrolling past here. They're doing stuff with the names, extra funny stuff with the names, and fairs and families, and so. But at the bottom of it, this is where your random forest stuff is, right? So they're doing basically the same stuff, but random forest does could potentially make it a lot better or a lot worse. You never know what you're going to get. It's kind of like a box of chocolates. Let's see. How can I?
Oh, you sent the link, didn't you?
Well,
isn't it in the?
It is in the meetup. The question is, what happens when you go? That's a YouTube broadcast. So the question is, can I send you? Here we go. I'm going to stop sharing my screen, and I'm going to try and invite you.
Let me open up.
Kumodev at Gmail.
Yeah.
Look, it even knows you. It says, hey, that's Brian. All right, so I'll send that to you. Let's see if you can get the screen. I don't know that I have to approve anything at all. I'll just ship you up.
What is it? Email? Is it about Hangout invitation?
It was a Hangout invitation. Are you in? I could send it to you again. So here, I did this. I invited people, but can I hang out? Let me hang out chat to you real quick. Hang on.
No, I think I'm logged in with my other account.
You want me to send it to that?
You just sign out of that. Yeah, just send it to blp@gmail.com.
Sent to where? Was it?
BL Cooley.
Invitation posted. Oh, look at that. Okay. You perhaps.
Okay, cool.
Turn speakers off.
Yeah, I'm muted.
Hang on a sec. Oops, that's not
Might be my microphone.
Oops. Ah.
Sound hello?
I think so. Okay. Now, maybe that speaker shut up now too, so let's see what happens. All right. Can you screen share? It's on the, it's that left green arrow for that thing. All right, there we go.
So, so this is basically it's kind of like a Python version of a Mathematica notebook or something like that. It's called a Jupyter Notebook, and basically it's just a way to add a bunch of text easily and formatting, and then you also have in the notebook you'll have sections that have code in them, Python code, and you can execute the code. So so this is a Python notebook. This is actually from the Udacity machine learning nano degree. It's one of the very first homework, I guess. It's not even a homework. It's just optional, just to sort of get you familiar with working with data and that sort of stuff. I'm not going to go through all the description, but it's basically the same thing. It's the same data set that Alex showed, and the class provides a Python file called visuals.python that has some functions in it. Anywhere there's a vs dot something call, that's custom code that was written by the Udacity instructors. So it's not something that's in standard Python, but it's just to make it easier to like show graphs and do filtering on the data set without having to know like all of the pandas syntax. Pandas is a software package, like a library for Python, that emulates a lot of the stuff that is in R. I don't know if one was before the other and copied or whatever. They basically serve the same purposes, and one is and a lot of the concepts are the same, like data frames and that sort of thing. So so basically at the beginning we have some imports. NumPy is a numeric library for Python, so you can work with arrays and things like that. It's a lot faster than native Python lists, and it works very well with pandas. I think pandas probably relies on it. And so basically you just import these guys so you can call them later. When we make calls to NumPy and pandas, we'll just say np dot whatever the call is, or panda pd dot whatever the call is. And so basically the first thing we're doing here is we're loading a data set. We give it the file name, happens to be in the root directory of the snowbook, so or in the same directory, so we don't have to do any path work or anything like that. And then you can just display part of the data, and you can see it's the same data that we saw before. Passengers had an ID, a binary, whether they survived, what class they were in, as far as like class of service, their sex, their age, etc. So we're just looking at the data here, and so the first thing that we're going to do is just we're going to store whether people survived in a variable called outcomes, just for convenience. That way we don't have to reference the column. So the full data is the data set. It's this whole sort of matrixy array here that has all the columns and all the rows. You can reference a single column just by passing in an array notation in brackets the name of that column. So we're just saying, go get the series. It's called the series in pandas that is labeled survive, and stick it in this variable outcome so that we can use it later. And then we're going to drop that column from the data set and store that in the variable data. And so what we've basically done there is we've separated all of our potential features, which are variables that we would use to predict an outcome, from the prediction variable, which is whether someone survived or not. That way it just makes it easier to work with it down the road when you start fitting models, that sort of thing. Okay, and then the first thing we're going to do here is just define our own accuracy score. Later on, when you start fitting models, like when you fit a decision tree or random forest classifier, it will actually have there's an accuracy score function that you can import that will do the calculations. But here we're just rolling our own, and we're saying that we're going to pass in what the true set of data is. We're going to pass in our prediction, and our accuracy is just going to be we're going to compare the truth column to the predicted column, and we're going to get a 1 or a 0 from that. And then we're just going to take the mean of that, since it's 1 or 0. That'll give us the percentage that's accurate, of how accurate we are. And so if we just say, like, we're going to take the first 5 rows of outcome, and we're going to predict that everybody survived, and pass it into our accuracy score, we get an accuracy of 60%. And if you go back up and look, you'll see that. I guess it's not here, but I would expect that if we were to just say I have to actually reference that one that way.
So this is very similar while you're doing that. This code within a document is very similar to R Markdown. It's the same kind of thing where you can, it runs within the document.
So since I called this up again, I have to go back and enter everything for the, So below the first set of data, I'm just printing out the first 5 rows of the outcome series. You can see that there are three people survived and 2 didn't. So that's why when we predict here at the bottom that everyone is surviving, NP.1s, it's just an array of 1s, 5 1s. We get 3 of our answers right and 2 of them wrong. So then we're going to just start setting up some prediction functions and pass our data set in. And in the first set, we're just going to predict everybody. For every passenger, we're just going to append a 0 for our prediction of whether they survived or not. I think you did the same thing.
So they all die.
And so if we predict that everyone dies, then our accuracy score comes out to 61.62, which I think it was exactly what you had, right? Very close.
Yeah.
So that's just sort of giving you a baseline. And it's always important to do that, because if you have a data set that's really skewed, like if 80 or 90% of people die, and your predictor says, 78% of the people die, it's doing worse than just, it's doing worse than just a dumb predictor that said everyone died. So it's good to know what your baseline is. So we need to try to get above 61% in accuracy. Otherwise, we're not even doing better than just a blanket assumption. So, and then this is where we start using there's a library called Matplotlib, which is used heavily in this VS script that's provided to you. And basically, we're just taking our feature set and our outcomes and passing it, and we're filtering on one particular feature to see how things vary. So if we just look at the sex, we see that a high percentage of male passengers died and a low percentage of female passengers died. So we can use that as our first pass in updating our predictions function to say, and we're just writing a decision tree here. We're just hand rolling our own decision tree and saying, let's look at each row in the set. And if they're a female, then we're going to predict 1. And if they're a male, we're going to predict 0. And see how that improves our predictions. I should add that this is really not, like, the syntax here, it looks really clunky because we're like writing a for loop here and we're iterating for each row, and that just seems so like, why are we doing that? We could be, but you can actually, you could actually just set this by using pandas notation and just say, like, every passenger that, or in our, if we had kept the data set together, we could say, set the survived column. I think that's what it's called, survived column. Set the survived column to 1 if the sex column says female. You can just do it all in one shot. This is just sort of for people that haven't really done a lot in pandas, and they don't want you to get tripped up on the basically the syntax of trying to use a library you've never seen before. So anyway, we see that just by adding this one condition, we get up to 78.68, which sounds familiar. And so we'll just go break it down further. And this is sort of the manual procedure. We'll look at the age of males, and we see this nice little result here that all the males under 10 survived. So we'll just we can add that in. We'll just say, hey, if it's a female, we still will predict that they survive, but if it's a male and they're under 10, we're also going to predict that they survive. And that gets us up to 79.35. And then finally, this is another slice on the data. We're looking at the age, and not all of the females survived. We're saying that they all did, but maybe there's somewhere where it breaks, and we look at them, all the females in P class 3 here, and look at them by age. We see another block here, between 40 and 50, where all the females in that age group died. Who knows why that was the case, but yeah, maybe they were past childbearing age or something. Or so we just add that column in. Again, you can see this if else construct here is basically a decision tree that we're making ourselves. And when we do that, we got up to 80.36. I think you can get up a lot higher, maybe like 85, 88% without doing anything, without like severely overfitting. There's some other stuff you can do in this data set to get a reasonable amount. I actually got our goal was to get above 80%, and I stopped at 80.36%. the person who reviewed my project said, maybe you could go a little further. So I was like, hey, you know, this test of driven development, I met the requirements, I'm done. And that's right. That's right. You tried really hard. I want to, I'm just going to get out of this. If you don't mind, I'll show another data set.
Sure.
That is, this is also homework from the class, but this has more of the, so they gave us another project that was Boston housing prices. And it's, you know, it's a lot of the same stuff. But in here we're actually doing, we're doing more of the Pandas style working with the data, and also we're pulling in some things like decision tree classifiers and random forest. I don't remember what I used there. I think I used two different. I think we had to use three different classifiers here. So basically, the idea. Let me see if it has a good description up here. But basically, the idea here. This is a classifier, not a predictor. But the idea is that you have a data set of housing prices in Boston, and you have a set of features, and the features are things like what's the square footage of the house, what are the number of bedrooms, number of bathrooms, what's the neighborhood like, you know, what are the schools like, stuff like that, and then a price for the house. And then what you're trying to do is figure out how to classify, you know, where the house is going to end up being. So first thing we do is we just start out with some statistics. Again, what we did was we took the prices, we took the median value out and put it in a series called prices, and split the features out into another data frame by dropping this same median value column out of the data set. And then so then we're just going to calculate some statistics, and this is from the NumPy library, and we're just doing what you would expect. I wonder if I can make this a little bit bigger. Y'all see that now? All right. So yeah. So we just pass the series in, pass the prices series in. NumPy will compute min, max, mean, median, standard deviation, all that good stuff for us. And we see that, you know, you got a maximum price that's of $1 million, minimum price of 100, a certain mean, and a, you know, fairly large standard deviation. And so, yeah, so here it's discussed with the features. So the features are the number of rooms, the percentage of homeowners that are, you know, in some certain economic range, and then the student to teacher ratio in the school system. I think this is all just like, I mean, this might be real data from a long time ago or something. I don't really know, but it's certainly probably the maximum pricing house in Boston is not $1 million these days. So, but yeah, so anyway, like I said, so you have these functions that that you can import from. There's a library called scikit-learn or sklearn, and it has all of the models that you can fit, decision trees or linear, support vector machines, you can use like all sorts of fancy ways to fit either a classifier or a predictor. And so here we're just pulling the R-squared score from SK metrics, which is this is if you've ever done a linear regression, it's just the R squared of prediction. So this might actually be a prediction instead of a classification. Maybe I'm remembering that wrong. We'll see. Yeah, so then we're just going to test it out. We'll throw some data in and see how our model fits versus the real data, and we see that the R squared comes out to be 92.3 for this particular situation. And then we discuss a little bit whether that's good or not. I mean, 92.3 might be great, it might be terrible. It just depends on what the application is and what your expectation of being able to fit that data is. So here we're seeing there's some other functions that make life kind of nice. Now we're getting into the sklearn cross validation library, which has a train test split function. The nice thing about this function is you pass in a set of features and a set of variables that you want to predict. So in this case, features and prices, and you tell it like what percentage or what fraction of the data do you want to use as a test set, and then you can pass in some seed so that you can get the same result if you want to get it back later. So we're saying, well, let's take 20%, and it basically goes and splits your data into two different test sets that you can use, one for testing and the other for training. So train on a bunch of data, but save some so that you can validate and make sure that your data is okay. So we're going to start to fit. I don't think we've done anything yet. Again, we've got some functions here to help us. Did we train somewhere?
You made the set, but did you actually train?
I wonder. Anyway, I think this might just be an example. This is
model learning right there.
Yeah, and it is a decision tree. So these are learning curves, and the idea here of a learning curve is the green one is the testing score, and the red one is the training score. So basically, the way that training works is that you're fitting a model to data, and every data point that you add to the training set is going to improve your ability to predict. So your score is going to get your I'm sorry. Yeah. Basically, like as you add more data, maybe you have like a little bit of data and a lot of parameters. You're going to fit it perfectly, right? Like you have 2 points, you could fit a line perfectly with 2 points, right? So that's why your training set always starts at 1. And then as you add data, it will continue to go down, but it'll meet somewhere. It'll never like start going back up. It'll always keep going down as you add data for a fixed number of parameters, because you're never going to be able to fit them perfectly. And meanwhile, for the test set, usually what happens is as you add more data to the test set, you'll see it'll improve, and then towards the end it may start tailing off, which means that you've started to overfit up here, because what you really want is you want a model that fits for however many data points you give to your model to train. You actually want it to fit the test set better than the training set, because it's going to fit the training set. You're regressing the model to the training set, so it's learning, it's learning the data that's in the training set, but it's only useful if you can predict something that it hasn't seen, right? So what you want to see is that as you start giving more data to your training set, and you're regressing and sort of honing in on what the parameters for the model are going to be, you want to see this test score improve. And if you see something like this, where
where the test score starts to drop off, then that means you're overfitting. You have too many. You have too many parameters, which in this case would be the depth of our decision tree of 6 for the amount of data that we've given. You can see it here too, right? So it kind of peaks around 200 and then just trails off. And you can see that for a max depth of 10, like our score is really high, right? We're fitting the training set almost perfectly here. Whereas when we only had one max depth of 1, we can only get about half of the, we can only fit about half the training set because we just didn't have enough degrees of freedom to describe it. And as you increase the max depth, the score of your training set gets better, whereas the score of the test set, is going to vary depending on whether you're overfitting or not. So anyway, and then another way to look at it is complexity curves. And again, these are graphing functions provided. Let me just go back to where the training stuff is coming from. This is the same sort of thing. Now instead of whereas up here we had one plot for each max depth. Now we're plotting against max depth. So we're just varying it from 1 to 10. And you can see that, and then this is just the aggregate of all the data that's been passed in. And you can see that, as you increase the max depth, the validation score starts to go up, but then it starts to go down, even while the training score is getting better with an increasing maximum depth. And that's just describing what we just talked about. More and higher maximum depth in a decision tree means you have more breakpoints to make a choice and fit parameters. So your model will always get better. Whereas at some point you're overfitting and looks like about 5, somewhere 4 or 5 is the place to stop adding degrees of freedom there. So oh, that's why. Correct. All right, so okay, so here now we're finally getting down to it. We're so fit model. This fit model function is just a model, a function that we're going to use to basically handle a bunch of stuff at once. And we're also going to do a thing called grid searching. And the way that a grid search works is basically you pick something that the way that a grid search works is that you have a bunch of, what you want to do is to sort of maximize your use of data. What you're going to do is you're going to split the data into a bunch of different groups. And that's what we're doing here in this shuffle split example. And then we're going to run the grid search over all of the different sets that we come up with. And then we'll fit using whatever regress. In this case, we're choosing a decision tree regressor, and for each one of these CV sets that we calculated up here in the shuffle split method function, we're gonna do a fit, and we're gonna basically pick out the best estimator out of that search. But this basically, like, I guess the thing I want to say here is that this all comes from the scikit-learn library, and it's really hard to underestimate the amount of work that's being done here, right? So I want to fit a decision tree to my data, and all I do is, I say, give me a decision tree regressor, and then, I mean, you can pass other parameters and that sort of stuff into it. But basically, like, that sets you up to just pass data into this function. It's a pretty powerful thing to have. And then we're doing it with just a few lines of code. We're also doing these other things that would be like incredibly taxing to try to do manually, right? We're splitting our sets into, we're splitting our features into all these different disparate sets of data, and then we're gonna do a grid search over them based on a particular performance metric that we defined earlier. We did it on R², and we're just gonna pass the score into this grid search function. It's gonna fit all of these different data sets for us with this one regressor and give us the best estimator out of this, the set of over the grid.
So, in search normally, you're looking for a predetermined value. This one's going to find best value.
Yeah, I mean,
Well, you've got that scoring function. So are you looking? I'm not sure what the scoring function does, but that's telling you which one's best.
Yeah,
It's giving you some sense of what is the best one. So when you find it, and I guess you're running that regressor over all of the sets, right?
yeah, that's right. So this line here is saying, take whatever regressor you define, decision tree in this case, and then params is just we're doing a search. We're actually doing a search over a
varying depths of the trees.
Yes, sorry, varying depths of the tree, right? So we're going from a max depth of 1 to a max depth of 11. It's going to search of that function.
Find when it stops
and
diverging.
Yeah, actually, I'm wrong. It's not splitting the sets into it's not doing testing over different sets. It's splitting the data into a test and a trained set, and then doing grid search to search over all of these different values of max depth. So instead of me having to run a regressor and change the depth and run it again, change the depth and keep running it until I get 10 different values of the max depth, this just does it automatically for me. And then at the end, it should spit out the decision tree that performed the best as I defined it. So that way you can fit a bunch of models at once and get something good, hopefully good out of it. And so that we're going to use it actually. And you can see that we just defined a function up here. So it's not actually doing anything, just waiting. That code's waiting for us to use it. Down here we'll use it, run it with passing in our training set, and it'll say, for this set, max depth of 5 is the optimal model. And we just got that, passed the regressor, the best estimator back to us, and we just said, hey, give us this max depth parameter for this decision tree regressor. And so, so then what we'll do, we're just going to pass in data. We're just converting all these features for different clients into a data set, and we're going to pass this data into the regressor. We're just going to call regressor predict, and it takes the regression model and fits it to the data that we pass in, and we see that So if we have a 5-room house with 17% poverty level and 15-to-1 student ratio, we get 428, which is pretty close to the median that we had before. And then client 3, has a huge house. It's 8 rooms, 3% poverty level, and 12-to-1 student teacher ratio, and that's close to the maximum value that we saw of 1 million. And let's see.
That's not the Mississippi discount.
I'm sorry.
That's not the Mississippi discount real estate.
Yeah, that's right. I think this is from 78. If that date, how relevant today is data that was collected from 1978? I don't know if that's when the data was from. Things could have changed a lot, basically. But
Before some of these people were born.
but yeah. So anyway, basically the thing I wanted to show. The biggest thing here is in the STIT model where you've got this decision tree regressor. You're testing 10 different values of max depth by just making a score and passing it to this grid search CV function to fit the training data that you put together. So I think this actually is an error, to be honest, because I think up here this shuffle split was going to compute a test size, and I just passed in the training data instead of passing in all the data. I could use more data than I did. So I still pass. So
Good enough.
Still pretty neat.
Thanks for showing it.
and I mean, there's a ton of stuff. I mean, if you
Classes you guys didn't teach statistics, statistics.
this was an online class for me. This is from Udacity. I don't know what they teach it.
You take a couple years of data structure, and maybe you'll have some of the basics.
What was the course name?
It's
Machine learning, something like that.
It's Udacity, and then they have yeah, so they have this machine learning.
Is there an opportunity to make a case study and submit it? Have they analyzed?
To these people?
Yeah.
I don't think so. You could probably.
Yeah, they're probably just an online kind of college.
Yeah, I mean, basically, it's just like. I mean, the nano degrees are paid. Like you have to pay. I think this is old. They don't do it this way anymore. But this one you pay a certain amount a month, and then they have new ones now that are like you do one term that's 2 to 3 months, and then they have a break and you do a second term. And, I mean, it's just they have job search strategy and all that great stuff. But
Are they worth it?
I mean, I don't know. I don't know if they're worth it or not. It's
I know a lot of use in the actuary field.
yeah, it's.
I'd say for me, it's interesting and you learn from it. But if you don't have a job where then you're going to immediately use it, it's tricky because then it's kind of in one ear and out the other.
Yeah.
Where it's neat to come back and have a case to use it.
So their Udacity's focus. There's a lot of different online courses that teach this stuff. Like, I mean, if you go to Coursera, they'll have.
I did Coursera.
They have some stuff too, and it's also a lot of it's paid now as well. But you can audit it and just like watch all the videos.
Right.
But the problem with the auditing is that they won't grade any of your work, so you don't kind of missing that feedback about.
You can turn it in something that's not
Okay.
like that. You can turn it in, but it doesn't.
Right. But I mean, these nano degree courses are designed to get you a job. That's pretty much, if you take them, that's the goal. Like a big chunk of this machine learning nano degree is like how to write your resume, how to do an interview, how to get your GitHub set up so that it looks, good to potential employers and that sort of stuff. So, and the reason that I took them is that I used to do a lot of machine. It's just basically linear regression is what we did. But I used to build models for process control in refineries. So I had a lot of the background already, but I wasn't a programmer. Like I didn't professionally program then. Spent the last several years doing mobile development. So like now I know a few different languages, and now I can use Git, and, Subversion, and other version control. I know about different aspects of software development. So I'm trying to learn. This is all for me to learn pandas and scikit-learn and other stuff, so that I can be more functional as somebody that does machine learning type work. So